Hey everyone, today I'm going to talk a little bit about the moving average technique for handling time series data. So hopefully you've read that a time series is a sequence of observations that are ordered somehow in time. So we're going to explore some time series data and see what we can gather from it. So first I suggest you open up the service calls Excel data file from eCampus. So one really simple, straightforward way that we can explore time series data is just a simple time series plot. So I'm going to highlight my calls data here so that we can see how the number of calls fielded each day, and we have 21 days, may fluctuate over that span of time. So I've highlighted my calls data, and now I'm going to go to Insert, and then I'm going to look at some different charts. Probably want to stick with one of these line charts. I like this line with markers, so there's a little circle for each day, so it's very easy to see which levels of or number of calls corresponds to which days. We've got a lot of empty space under here, so we can make some adjustments to the presentation of our chart to make it a little bit easier to see some of these changes over time. So by double-clicking the y-axis, I've now brought this Format Axis tab up, and if I click over here to the bar chart symbol, I can see my axis options. And what we see is that for bounds, I have a minimum of 0 and a maximum of 350. So that is our minimum at the bottom of the chart, and 350 is our maximum at the top. We don't really have anything until we're getting up past 250. So I'm going to change this minimum from 0.0 to 250.0. And now our chart looks a little bit different, but it's a lot easier for us to see that fluctuation and that randomness in the number of calls from day to day. So this is a really, really simple, basic, super straightforward way that we can look at time series data without even having to get too nuts with the math and statistics and data analytics stuff. But of course you're in this class, so you should find that stuff fun. But it's always important to choose the right tool for the job. So the moving average technique is among the most important approaches, or popular, for processing time series information. And the basic idea is that you're computing the average of a fixed number of the most recent observations. So for example, a 3-period moving average is formed by averaging the 3 most recent observations. It's a moving average because as observations are added, the newest observations are included and the oldest are dropped out. So let's build a 3-day moving average with our service call data. So I'm going to call this 3-day just so we remember what it is. And then I'm going to compute a 3-day average. I can't do it for the first day because there's no day before that. We can't have a negative number of days. So in cell C3, I'm going to ask it to calculate the average of cells B2 through B4. I'm just going to highlight those cells. If you were doing this by hand, you would sum up the value of 309, 292, and 284 and then divide it by 3. When we're working with a computer like this, we don't have to do that. We can just tell Excel to take the average of those 3 values. With that done, I'm going to copy that value and I'm going to drag it all the way down to day 20. And I'll hit Control V to copy it in. And now we have our 3-day moving average. And now that we've calculated our 3-day moving average, we might want to add it to our chart. And we can do that by clicking anywhere on the chart area and then clicking the funnel. Then down at the bottom of the funnel, you can select data to add to the chart. So now I'm going to go click Add here under Legend Entries because I want this to be formatted in the same way that I want our calls data formatted. So I'm going to click Add, here where it asks for series name, That's in cell C1. We've called it 3-day. And then for our series values, we want to highlight the cells in column C. And now we see an orange line has now populated our chart, and I'm just going to click OK to get out of here now that we have it added. And you might see that the ridges and valleys of our data now seem less extreme, that our highest highs and our lowest lows are kind of smoothed out and moderated just a little bit. I mean, looking here around day 17, our low is 290, but by using the 3-day moving average, it's been smoothed out a bit, and now it's probably about 304. So here we can really see the effect of using these smoothing techniques to kind of help smooth out and account for some of that randomness and stochasticity that we encounter every day. So sometimes we want to forecast and try to figure out what to expect in future days, and we can actually do some forecasting, at least for a day or two, using these moving average techniques. And in fact, that our estimate here for day 2, our mean, our 3-day average, or mean, or y bar, it represents the average for days 1 through 3. And that's the most updated estimate of the time series prior to period 4. So if we want to estimate our value on day 4, we will want to just take the average of the number of calls on days 1 through 3. So here on day 4, if I want to, or here on day 4, which is in row 5, if I want to predict what this value might look like, I would average the values from days 1 through 3. So to do that, I would use the equal sign, average, and then I would highlight cells B2 through B4. And that is now my forecasted or expected value. And as you may recall from regression, this expected value that we calculate is often called y hat. So I'm just going to call it y hat. And again, I can copy this down the column to gather that forecast data. And I can go even a couple days past the data I have to forecast. So here on day 22, we would expect between 320 and 321 calls, and on day 23, we would expect 318. So that's kind of a cool function that we can work with, and having this estimated value helps us evaluate whether or not this 3-day moving average would be as good as a 5-day moving average, for example. So to evaluate our model, we want to calculate the MSE, the MAD, and the MAPE, and then identify the model with the lowest values for these calculations. So we're not comparing this model to any other models, but if, say, perhaps in the homework, you were comparing a 3-day moving average and a 5-day moving average, you would want to calculate these values and then determine whether or which one has the lowest overall values for these separate calculations. So in our attempt to calculate these statistics that will help us evaluate the model, the first thing we need to do is calculate the forecast error, which is often indicated as E sub t. I'm just going to call it error up here in cell E1. And then in cell E5, I'm going to calculate the error. Just like when we worked with simple linear regression, the error is the difference between our estimated value of calls and the actual value of calls. So what we want to do is subtract the number of calls from our estimated number of calls. And to do that, we subtract From B5, we subtract C5, or D5. C5 is our moving average. D5 is our estimated number of calls on day 4. So that number is -1. I'm just going to copy that cell and drag it down to E22 and paste it just so I can get all that information at once. So now we're going to want to go ahead and calculate our mean square error, or MSE. And for this, we need to sum the squares of the error terms and divide by the number of observations for the error term, which in this case is 18. So I'm just going to call this column MSE to make it a little bit easier for us. And then in cell F5 here, we are going to take the value from column E and square it. So E5, our little caret, and 2 to square it. And I'll copy that and I'll drag it all the way down. And now we have the individual values. Now I need to sum these and then divide them by the number of observations. A nice trick that helps you count things in Excel is that if in this case where we have cells F5 through F22 populated, I can just highlight these cells, and then at the bottom it actually gives me the count. So it tells me how many of them that I have highlighted. So now I know that I'm dividing by 18. So in that case, I know that I now want to sum the values I have in column F in cells F5 through F22. I want to sum them. So sum, put those in brackets, and then I want to divide by 18 because that's the number of observations between F5 and F22. So here we see that our mean squared error is 208.9. The next thing we want to go ahead and calculate is the mean absolute deviation, or MAD. So I'm going to call this column MAD just to, again, make life a little bit easier. And we need to sum the absolute value of all of the error terms and then divide by the number of observations that we have. So in column F, we squared our error, and in column G, we're now going to take the absolute value. And to do that, we use the ABS function. And I want to take the absolute value of what is in cell E5. I close that bracket, and then I can copy it, and again, I can drag it all the way down to G22. So now I have the absolute value of the error, and I want to take the sum of this absolute value and divide it again by 18. That's the number of observations we have. So here we see that our mean absolute deviation is 11.85. The last calculation we want to make is a little bit trickier. It's our mean absolute percentage error, or MAPE. And for this, we want to calculate the absolute value of the error term divided by the observed value of y. Before we get started, I'm going to title this column MAPE. So here I want to take the absolute value of our error divided by the number of calls. So for error, that would be cell E5 divided by cell B5, which is our observed number of calls. Now that I have that, I'm going to copy it and then highlight down to row 22, paste it, and I have all these values now. And to calculate the exact value now, I want to sum these values, then I want to multiply them by 1/18, and then multiply that value by 100 to have it expressed as a percentage as opposed to a ratio. So to do that, in cell H23, we are going to take the sum of the values we just calculated in column H. We're going to multiply that by 1 over 18 and multiply that again by 100 to convert it into a percentage. And what we find is that our mean absolute percentage error value is 3.92. So you can use this information if you're trying to figure out what moving average would be most appropriate given your data set. Sometimes a 3-day moving average works, sometimes a 5-day moving average is good. You can do a moving average with any time interval. The longer the interval is, the fewer observations you'll be able to predict, but some data sets work better with different distributions than others, and you'll have the opportunity in your homework assignment to look at 2 different moving average periods and then comparing which one you think best represents the data. So don't forget that when you're comparing moving averages, you're looking for the result with the smallest values for our MSE, MAD, and MAPE statistics. Try it out and good luck.